Atlas isn't alone. It's surrounded by 1 trillion objects, and they're not evaporating. Throughout November 2025, as Atlas moved away from the Sun after its October perihelion passage, astronomers captured images showing something extraordinary: a teardrop-shaped glow extending about 1 arc-minute toward the Sun, not away from it like a normal comet tail, toward it. An anti-tail pointing directly at the solar disk, stretching approximately 54,000 kilometers in front of Atlas. Here's why that's impossible naturally. Radiation pressure from the Sun pushes material away. Solar wind blows gas and dust outward. Comets develop tails that point away from the Sun because physics demands it. Material gets ejected from the nucleus, and the Sun's energy forces it backward along the comet's trajectory. But Atlas has a teardrop pointing forward, toward the Sun, maintaining this configuration both while approaching perihelion and now while moving away. The geometry stays stable. The angular extent remains consistent. That shouldn't be possible if we're watching normal sublimation of ice and release of dust. Avi Loeb just published the explanation, and it changes everything we thought we understood about what Atlas is carrying. The anti-tail isn't gas, it's a swarm, a massive collection of solid objects traveling with Atlas, positioned between Atlas and the Sun due to the mechanics of non-gravitational acceleration. Here's how the physics works. JPL Horizons has measured Atlas's non-gravitational acceleration at about 0.0002 times the Sun's gravitational pull. That acceleration pushes Atlas away from the Sun at a tiny but measurable rate. The acceleration scales inversely with the square of distance from the Sun, exactly like gravity itself, which means the ratio between the two forces stays constant throughout Atlas's orbit. Now imagine Atlas is surrounded by objects that don't share this non-gravitational acceleration. Atlas gets pushed away from the Sun slightly faster than these objects do. The objects, responding only to the Sun's gravity, fall slightly closer to the Sun relative to Atlas. Energy conservation and orbital mechanics dictate exactly where these objects must be positioned to maintain stable trajectories. The math gives a precise prediction. At Atlas's current distance of 270 million kilometers from the Sun, objects with the same velocity but no non-gravitational acceleration would be displaced sunward by approximately 54,000 kilometers. That displacement corresponds to an angular separation of 0.7 arc-minutes in the sky. The observed teardrop points toward the Sun and extends 0.7 arc-minutes. The calculation matches the observation perfectly. But here's where it gets extraordinary. Think about what's required to create the brightness we're seeing. 1 trillion objects. That's 10 to the power of 12 individual pieces, each one reflecting sunlight. Even if the total mass in this swarm is only 0.1% of Atlas's mass, the combined surface area would be 100 times larger than Atlas's own surface. 1 trillion objects each reflecting sunlight, creating the glow we see. That swarm would reflect 99% of the total light coming from the Atlas system. Only 1% would come from Atlas itself, and that matches exactly what Hubble Space Telescope measured back in July. The coma dominates the brightness. The nucleus contributes less than 1% of the light. Loeb's swarm theory explains the Hubble data perfectly. Now here's the smoking gun that separates natural from artificial. These objects don't evaporate. Normal comet material sublimates under solar heating. Ice turns to gas. Dust gets blown away. The composition of natural cometary debris changes constantly as volatile materials boil off and disperse into space. But the teardrop configuration around Atlas has remained stable. The angular extent stayed consistent as Atlas approached the Sun, and continues to stay consistent as Atlas moves away. The swarm maintains its geometry, its surface area, its light-reflecting properties. That stability means these objects aren't sublimating. They're not evaporating. They're not losing mass to solar heating. That's not natural for comets. Ice doesn't stay frozen when you heat it. Volatile materials don't remain stable across varying solar distances. Natural cometary material changes, disperses, and disappears as the comet moves through its orbit. These objects aren't changing. They're maintaining formation. 1 trillion pieces holding stable positions relative to Atlas, reflecting sunlight consistently, not evaporating under solar exposure. Remember the mini-probe theory? The speculation that Atlas might deploy smaller objects toward planets? This is the deployment. 1 trillion objects. Not released at perihelion as we theorized, but traveling with Atlas the entire time, maintaining formation through gravitational mechanics and non-evaporating composition. This explains everything about the anti-tail, why it points sunward, why it maintains stable geometry, why it existed before perihelion and persists after perihelion, why the brightness matches what Hubble measured, why the angular extent matches what orbital mechanics predicts. The swarm theory solves every puzzle the anti-tail presented. It's elegant. It's mathematically precise. It matches observations perfectly, but it raises the most important question of all. Loeb ends his analysis by asking directly, what is the nature of these objects? Are they rocky fragments or something else? Rocky fragments would be the natural explanation. Debris from interstellar collisions during billions of years of travel through space. Atlas picking up an entourage of solid material that doesn't sublimate because it's already been processed by cosmic radiation and stripped of volatiles. Or something else. Objects designed not to evaporate. Components built to maintain integrity under solar heating. Technology intended to survive, deployment, and maintain formation. 1 trillion mini-probes, each one a separate functional unit, traveling together as a coordinated swarm. 1 trillion objects that don't evaporate. That's not comet behavior. That's not how natural debris acts around icy bodies. That's either the most unusual collection of rocky fragments ever observed, or it's something designed to behave exactly as we're observing it behave. Are they rocks? Or something else?